Okay, so if you've ever tried to build a real application with a large language model, you definitely know the feeling. One minute, it feels like pure magic, and the next, it's just a complete mess. Well, today, we're going to break down exactly how you can tame that wild unpredictability and actually turn that raw AI intelligence into a rock-solid system that's ready for production. All right, let's kick things off with a problem that I'm sure hits home for a lot of us. You spend all this time crafting the perfect multi-step prompt, something like, hey, analyze my recent spending and show me some trends. And yeah, it works beautifully in your test environment. But then you push it to production and suddenly it's failing, it's hallucinating, it's giving you totally inconsistent results. So, what is really going on under the hood? This right here, this is the chaos of what's known as the one-shot request. We're basically just throwing this big, complicated problem at the AI and, crossing our fingers, hoping for the best. It's like we're treating it like some kind of magic black box. But production systems can't run on hope. They need order, they need reliability, and you have to have a way to debug things when they inevitably go wrong. So, how do we fix this? Well, to bring some much-needed order to that chaos, we're going to introduce two really important components that act as orchestrators for our AI. Meet the router and the planner. Honestly, these are the secret ingredients to building a truly robust system. And probably the easiest way to think about these two is with a pretty simple analogy. Imagine the router is like the receptionist at a big company. They don't do the actual work, right? But they know exactly which department, or in our case, which tool, to send your request to. Then you have the planner. The planner is the project manager. It takes that big, complex goal of yours and breaks it down into a super clear step-by-step plan. And this distinction seems simple, but it is incredibly powerful. The router figures out where the request needs to go. The planner figures out how the work is actually going to get done. This separation is frankly fundamental if you want to build any kind of scalable AI system. Okay, so let's see how this actually works in practice. What we're going to do is follow one single complex request on its journey all the way through this orchestrated system, from the moment the question is asked to the final result. All right, here's our query. Get my last 5 orders and summarize spending trends. Now, on the surface, that seems pretty simple, right? But it actually involves a bunch of different steps. You've got to fetch data, do some calculations, and then summarize everything. If you send this directly to an LLM, it's a total gamble. But in our system, the first stop isn't the LLM at all. It's the router. And boom, the router does its job perfectly. It takes one look at that query and instantly recognizes, hey, this isn't just a simple chat question. It understands the intent, involves data retrieval and analytics, so it does the smart thing and sends the request right on over to our specialist, the planner. Okay, now it's the planner's turn. And instead of trying to tackle this whole thing at once, it breaks down or decomposes the request into a really clear, logical sequence of small, simple actions. You can think of this plan as the blueprint for getting the task done reliably, every single time. And this is the crucial insight right here. We are separating the thinking from the doing. The planner's only job is to think. It creates the strategy. It doesn't actually execute anything itself. That job gets handed off to another component, the executor, which is responsible for carrying out the plan step by step. And this slide just illustrates that doing part perfectly. The executor grabs that plan, and for each step, it routes it to the best tool for that specific job. So notice what's happening. The LLM is only being used for what it's really good at, like understanding trends and summarizing things. All the structured tasks, like fetching data or doing math, are handled by much more reliable and deterministic tools, like a direct API call or a simple Python script. So what's the payoff for building your system this way? Well, it's huge. Because you're using the right tool for the right job, you dramatically slash the chances of the model just making stuff up, hallucinating. The entire process becomes way more reliable. And maybe best of all, especially for us developers, if something does break, you can see exactly which step failed. That makes debugging about 1,000 times easier. All right, so we've seen how it all works. Now let's kind of zoom out a little bit and look at the core design principles that really make this type of system so robust, so maintainable, and truly ready to handle production scale. There are really 4 key principles at play here. First up, you've got modularity. That just means each component has one single clear job. Second is composability, which is awesome because it means you can reuse little steps like fetch orders in totally different plans. Third, deterministic control. You are taking back control and not letting the LLM's randomness run the show. And finally, observability. You can log and monitor every single step, which makes it so much easier to find and fix problems. And look, just to be super clear, this isn't some abstract theoretical concept. This exact multi-layer orchestration, routing, planning, and then executing with tools, this is exactly how the biggest players in the game, we're talking OpenAI, Google, Anthropic, this is how they build their production-grade AI systems. Which brings us to probably the most important takeaway from this entire thing. It's really about a core mental shift you have to make when you're building serious applications with AI. Listen, the raw intelligence of a large language model it's just incredible. It's a genuine breakthrough. But, and this is a big but, that intelligence by itself is not a product. It's a component. And to build something that your users can actually rely on day in and day out, you need orchestration. And that is the transformation we're talking about. Without this kind of structure, all you have is raw, kind of chaotic intelligence. But the moment you add a planner, you add that orchestration layer, you no longer just have intelligence. Now, you have a system that's reliable, that's debuggable, and that's ready to scale. So we'll leave you with this thought. You now have the blueprint. You know how to move beyond just throwing simple prompts at a model and how to start building real, robust, AI-powered applications. The only question left is, what are you going to build?